Here we wanted to solve this differential equation using Laplace transform. So very first step is apply Laplace transform on both sides. Therefore we get Laplace transform of y double dash minus 2 times y dash plus y. It is equals to Laplace transform of e to the power minus 2 times t, and Laplace transform satisfy linearity property, so therefore we can separate it. Laplace of y double dash minus 2 times Laplace of y dash plus Laplace transform of y, and it is equals to 1 upon s plus 2. Since Laplace transform of e to the power at, it is nothing but the 1 upon s minus a. This is the standard formula, and using that we can say Laplace of e to the power minus 2 times t, it is 1 upon s plus 2. Now we wanted to find Laplace of y double dash y dash. So let me recall some formulas. Laplace transform of y dash of t, it is equals to s y of s minus y of 0, where y of s, it is Laplace transform of y of t, and a Laplace transform of y double dash of t, it is equals to s square y of s minus s times y of 0 minus y dash of 0. So if you substitute these two values of y dash and y double dash in above equation, so therefore that equation becomes, so therefore first term we have to write this much, s square y of s minus s times y of 0 minus y dash of 0, and second term is minus 2 times Laplace of y dash, that becomes minus 2 times s y of s minus y of 0. Last term is Laplace of y, which is y of s, function of variable s, and right hand side is 1 upon s plus 2. So this expression becomes this. Okay, next we have values of y of 0 and y dash of 0. They are given values, you can see here y of 0, y dash of 0, both are 0. We can substitute those values here. So therefore s square y of s minus s times 0, it will be 0 minus 0 minus 2 times es y of s minus 0 and plus y of s, which is equals to 1 upon s plus 2. Now collect the coefficient of y of s at left hand side. So therefore s square, from this we can see minus 2s, okay, and last is 1, so plus 1 times y of s equals to 1 upon s plus 2. Now divide both sides by this s square minus 2s plus 1, so therefore y of s equals to 1 upon s plus 2 into s square minus 2s plus 1, which is further equals to 1 upon s plus 2 into s minus 1 whole square, because expansion of this s minus 1 whole square, it is s square minus 2s plus 1. Now our aim is to find y of t, that is the solution of given differential equation, by applying inverse Laplace transform. So therefore apply inverse Laplace transform, inverse Laplace transform. So therefore Laplace inverse of y of s is equals to y of t, and which is equals to Laplace inverse of 1 upon s plus 2 s minus 1 square. Okay, so our aim is to find Laplace inverse of this term. You can use convolution theorem, you can use partial fraction method, or you can use any other adjustment to find out the Laplace inverse of this expression. Okay, so I will use some adjustment and then I will use division by s property. So I can adjust this way, Laplace inverse of 1 upon s minus 1 plus 3 corresponding to this first term, okay, and second term I am keeping as it is, so s minus 1 square. Now we can see it looks a function of s minus 1, so therefore by using first shifting property we can say it is equals to e to the power t Laplace inverse of 1 upon s plus 3 into 1 upon s square, right? Now our aim is to find Laplace inverse of this function, this new function. Okay, so for that purpose I will consider only Laplace inverse of, let me call this equation number 1. Now consider Laplace inverse of only 1 upon s plus 3 term, okay, and using the standard formula we have, it is equals to e to the power minus 3t. Now therefore by division by s property, so let me recall division by s property. If Laplace inverse of f of s is f of t, then Laplace inverse of 1 upon s f of s, it is equals to integral 0 to t f of t dt. Okay, so here we have Laplace inverse of 1 upon s plus 3 equals to e to the power minus 3t. Let me call this as a f of t. And now therefore by above property, or you can say division by s property, we have Laplace inverse of 1 upon s plus 3, it is equals to integral 0 to t e to the power minus 3t dt, and this is equals to e to the power minus 3t divided by minus 3, limits from 0 to t. Okay, so if we put upper limit t, so we will get, therefore it is equals to e to the power minus 3t divided by minus 3, and at lower limit we will get plus e to the power 0 divided by 3, and therefore Laplace inverse of 1 upon s plus 3, it is equals to corresponding to second term, it is 1 by 3, so 1 by 3 minus e to the power minus 3t divided by 3. Okay, now one more time we have to use division by s property, because there is a s square term you can see here. Okay, so therefore again by using division by s property, we have Laplace inverse of 1 upon s square s plus 3, and this time it is integration of new f of t, that is 1 by 3 minus e to the power minus 3t divided by 3 dt. Okay, now take the integration of this term, so therefore it is equals to 1 by 3t minus e to the power minus 3t divided by that is minus 9, right? Because we have, this is 3 already there, so it becomes minus 9 and limits from 0 to t. Okay, so therefore it is equals to 1 by 3, upper limit is t, so 1 by 3 t and plus e to the power minus 3t divided by 9. Okay, lower limit is 0, so this, therefore first term will become 0, and second term, that is minus e to the power 0 divided by 9. Okay, so therefore we get Laplace inverse of 1 upon s square s plus 3, it is equals to t upon 3 plus e to the power minus 3t upon 9 minus 1 upon 9. Okay, but that's not the final answer. Final answer is what? We have to substitute. Let me call this equation number 2. Substitute equation 2 in equation 1. So therefore putting 2 in 1. What is 1? 1 is this Laplace inverse of given function. Here we have e to the power t times this much, so we have to substitute that value here, so we have to multiply equation 2 by e to the power t, right? So therefore y of t equals to e to the power t, in bracket we have t upon 3 plus e to the power minus 3t divided by 9 minus 1 upon 9, and that gives us required answer. Y of t equals to t e to the power t divided by 3 plus e to the power minus 2 times t divided by 9, and last term is e to the power t divided by 9. That is the required answer. You can verify your answer by putting given conditions. So first given condition is that y of 0 equals to 0. Okay, so if you put t equals to 0, it becomes y of 0, and let us see right hand side, so t into e to the power t, so this becomes 0, second term 1 upon 9, and last term e to the power 0, also 1 upon 9, so 1 upon 9 minus 1 upon 9 equals to 0. Yes, it satisfies first condition. Similarly you can verify second condition. Okay, so this is about the use of Laplace and inverse Laplace transform to find out the solution. Okay, thank you.